The next presentation on mapping will be made by Mr. Demidenko, Deputy General Director in charge of research from Panorama Design Bureau. This is our long-standing friend, and I think we have been working in tandem for many years now, dealing with many Russian companies. We work on policy issues. PhotoMod is used to process aerial and spaceborne imagery, and Panorama system is used for mapping applications. So we have this processing cycle. So I'm glad to see you. Thank you very much for the opportunity and for the introduction. Good afternoon, ladies and gentlemen. Unfortunately, my presentation is in Russian. I did not expect General Director of the company to set the scene. Nevertheless, I have a printed report which I will refer to from time to time, but I will provide you with footnotes. So mapping is defined as science of modeling, research of Earth, and technological processes involving creation of maps and various mapping models. Electronic mapping involves tools and instruments that allow you to effectively visualize and analyze digital spatial information. As we can see, in case of paper info, we would need two elements, one map and the other photo map. And in case of electronic mapping, we can effectively merge these layers. An e-map on the page on the screen of a computer depicts layers of thematic information, attributes, space images, matrices of heights, photo, video, text documents. Users have long been accustomed to using Google or Yandex, and they don't think much about technological capabilities that go into these wonderful services. Services underlie any electronic mapping. In order to address management issues, you need maps of different scale, which we heard from Professor Gottfried Konechny. He walked us through the history and evolution. I know that many states did not respond to the survey because of certain map restrictions, but open companies such as OpenStreetMap show in a wonderful way how one can use information on digital information and how to provide access to it for regular citizens, share it, and create a public service.
So the information in different scales, which is official, we know that it is available in digital maps of different scale, and this information in electronic mapping can be packaged together in electronic atlases, and as web services they are in form of tiles, tile coverage, and with screen scaling, information can have a different level of visualization or detail. Jointly with the topographic information, it is equally important to use the information about relief. In case of simple visualization, by viewing it by eyes, this information can be shown in form of shadows or shades, which is overlaid over topographic information. An important source of data for electronic maps are industrial databases. Industrial databases are usually stored in sub-D databases, and they contain a lot of attributes of sensors and electronic documents. All the information having spatial referencing, be it coordinates, or something else can be visualized on the map in form of layers. This slide shows the information about the graphing of nomenclature sheets. They are taken from the state register, the positioning of nuclear power plants. This is the database of the Minister of Emergency Management, and also a railroad database system and airports of the world. Unfortunately, you cannot see it here. Small blue planes. This is the database of the Russian aviation agency. To visualize the industrial data, we use special methods of thematic mapping. Most popular of them would be coloring, different colors for effective visualization. Usually we use same coloring shades for the same industry, where you can see the darker the color, the higher is the density, lighter the color, the less is the density. And for coloring, we use polygonal sizes like the boundaries of the state or territories within the state to quickly understand the main idea behind this. Additionally to coloring, we use technology of graphics and diagrams. Such conditional symbols are linked to polygons. This method can ensure comparative analysis of a number of indicators. For visualization of continuous indicators like the absolute altitude of relief, we use regular models of matrix or grid, as it is generally understood by international mappers. For visualization of metrics, we use all sorts of palettes, and for the relief, we have differences colors from green to brown. Green is higher and brown is, green is plain, brown is mountain, and also same approach for different depths of the sea. And if we look at the phosphorescent soil, we use same color, so again with a different distinction. But significant part of this thematic data cannot be classified simply by colors. For their mapping, we use a special system of symbols. Such special industrial data are numerous. Most of them, which are important for the state, have been state standardized, like marine and aerial navigation information are standardized at the level of international cooperation. All the organizations who do this mapping are obliged to use these symbols. For geology, we use special industrial data. Each state uses its own data, like the agricultural data, for instance, are not standardized in any way. That is why the symbols can be understood only by reading the legend of any paper map. In case of a digital map, each time the legend is new. Despite the existence of different standards, often users need to analyze an electronic map in different visualization. Most of the suites and software for visualization, they offer the so-called customization solutions, which can change the gamut, brightness, and contrast of colors and different layers of the map. By using the possibility of the customization of the map, users can simultaneously view different layers of spatial data and analyze them. The paper maps are 2D, and digital maps, as we know, can use the third axis of coordinates. Electronic cartography can visualize nth dimension as well. And here you can see the interface of monitoring analysis of geo-informational surface of the Earth. In the points depicted in different colors here, so these are the observation boreholes, where they automatically measure the level and temperature of groundwaters and their chemical and electrical properties and the temperature of ambient air. In these indicators, or based on these indicators, we automatically generate the distributed characteristics in form of grid and matrices. by, of course, suppressing the noise, and the users can get in an automatic mode an image in form of matrix and ISO lines, and also analyze on the graphs the selected characteristics in particularly selected points. For the matrices generated for different points in time, we also prepare the so-called temporal series of data, and which can also be visualized at different moments in time. They can be seen in form of a cartoon, and of course, the temporal line. We have a runner there, and you can put your runner on a different point in time and see the visualization at this point in time. So basically, the researchers have a very powerful visualization tool, which allows them to see on the diagram some kind of peaks, and then they can see why this field changed so drastically at this particular moment in time. And with the use of such methods, the specialists of the Russian Hydrospatial Geology Agency perform all sorts of assignments from the Ministry of Emergency Management to forecast possible sites for earthquakes, and their forecast accuracy is quite high. On the previous slide, you could see the points sporadically distributed on the map, but what happens if there are too many spots of points? For that, we use the method of clusterization. When scaling, the closely located objects are united into clusters and are shown by a single symbol. Often, over this symbol, we can see the explanatory note with a number of sites included there in cluster. And with changing the scale, we can see larger clusters, and or if you increase the scale, then you can see this particular point separately. It can be done in form of standard markers or symbols, or in form of symbols which depend on a number of characteristics, whether a color or size changes depending on the attributes. Electronic map is clickable. Basically, when we click the mouse on it, you can visualize all sorts of attributes present there. To visualize data, most of the packages offer universal means and the so-called form constructors, when you can customize the interface to get the data from or retrieve the data either from the industrial database or from the map. At the same time, we apply the technology of the so-called in-depth trial down, when starting from the viewing of some small series of data, you can go deeper into also, or you click on the hyperlink and analyze the information form of diagram. Everything can be done using the tools of electronic cartography. Using the instruments of analysis from the industrial databases can be shown on the electronic map, and with the change of the indicator, you can see the change in the colors and everything. Here on this slide, you can see the elements were about the tax collection. And at the end of the month, the system does the automatic recalculation of the indicators based on the monitoring. You can see the aggregate information about law-bindedness, and based on this, you can see different shades of color from green to red. Green means that here for this property section, meaning that all the taxpayers pay their taxes. Yellow means that some, but they didn't pay taxes, and red means that this area has serious problem in paying taxes. There are different options of symbolization of these objects, and this technology of symbols is changing all the time. This slide, based on the geoinformation technologies Panorama, shows different options or solutions for the so-called smart symbols, which can manage symbolization by writing your own program code. So the users can implement this interface themselves. It is easily integratable into GIS environment, and by this you can create your own system of symbols. A few examples. like for instance the visualization of river where the depth changes from the source to the delta, and the spatial polygon whose altitude is automatically calculated by its volume and height, and the graphical file with a link in the semantics of the object, and the electronic Excel table as a conditional symbol, circle with different concentric shades of color, and a special symbol on the map, which is in line with the map itself. And there are different options like that. Aside from the static information, the electronic map can help you visualize moving objects. And you can see the movements of the objects based on the conditional symbols, and you can see information about the route of the transport of a vehicle, type of vehicle. Aside from its positioning, you can see the tracks of the sites, and additionally, you can visualize their characteristics as well. Based on the navigational data, coordinates, course, speed, and the data collected from the sensors, video cameras, and some additional information coming into the system, these systems can form the so-called monitoring events. The most popular of them is clear, like the traffic jams or possible traffic accidents. But this is more of a global thing. But there are also much more narrower things which are of interest to particular agencies, like internal economic logistics, for instance, where using different symbols you can visualize the locations of unplanned stops of transport, or unique things when you can characterize simultaneously navigational indicators from a number of objects and their location to each other and characteristics of the sensors. Here you can see in symbols that this combine harvester is unloading its bunker beyond the truck which is registered in the system as an in-house system, meaning that they're offloading it to some other truck, unregistered truck. It's very popular with commercial companies who monitor their operations. What stands behind this electronic mapping? Use, first of all, the software, dedicated software. Here we have a typical solution based on the Panorama software, which can provide such electronic services to visualize the data. Digital maps and data from the databases can be seen here on the GIS server. For that, we prepare an environment of LAS names. And for the technologies applied online, we use special GIS service product, which shows them in form of protocols. There are VMS, VMTS layers, and these layers can be available for thin clients and browsers and other GC protocol compatible devices. And based on these Panorama products, I will speak now about the applications for these services. Geoportals. Geoportals are a means of operational search for sets of geospatial data. We put in the name and see the sets of data series that we want to get, and can download this information in form of the maps that this geoportal can offer to us. But not all products can understand all these formats. There are popular online layers that I mentioned already, and they're also on those geoportals. You can see publication of data on URL of different layers. And owing to such layers, we can implement the so-called infrastructure of geospatial data, which helps us to combine within this software different layers. Such layers could include, like in Russian Federation, for instance, basic spatial data, which are provided by Russian Register, Cadastre Agency, and boundaries of different properties, and then satellite images from Roscosmos, although most of it can be acquired from the open sources, but I'm talking about official information now. Also information about territorial planning provided by the Ministry of Economic Development, agricultural lands from Ministry of Agriculture, and a number of other agencies who share this information. All of these layers can be used in the software for their subsequent integration, and the term interoperability for the software can characterize the capability of the system or product to be compatible with other systems or products without any restrictions. So it turns out that within this application, you can shape up the composition of this map by combining layers from different sources. As a result, you get a mix of this, and by using all those capabilities of the service that I mentioned earlier, you can visualize and view them. Like here, for instance, you can move it aside. You can see the topo information or the cadastral information superimposed over it. In my presentation, I didn't mention about 3D visualization and in electronic cartography. In fact, this is a dynamically developing line of business, and from what I heard from Mr. Konechny, and that American representatives at their state structure level are not interested in promoting these technologies, sounds a bit unlikely. Maybe they have their own idea behind this, or maybe it is related to the lack of funding, because the support of these technologies is quite cost intensive. It requires a lot of funds, and the possibilities of this visualization can make the map alive. When starting from the globe of the Earth, you can view any particular building in form of content or photos, like Google and Yandex can do this, and you can view the 3D model, where you can see not only the digital elevation model, but also other types of altitude calculations, and you can overlay orthophoto on top of it, very realistic images, and this you can get operational information and make quick decisions about it. And I think that this is the future of electronic cartography, and in the coming few years, we'll see very unique software solutions with their inbuilt systems of geo-browsers with 3D visualization, and that will be of the greatest popularity among both regular people and big corporations. Thank you very much for your attention. Now I'm prepared to take your questions. Thank you, Mr. Demidenko. Will there be any questions? Yes.
Showing the facilities that electronic cartography can offer. One of the difficulties may be the updating. What do you think about the updating? The updating requires completely different structures. You need object structures, which have been proclaimed, for example, CityGML and so forth, as an international standard. But we are not very sure whether the governments are ready to implement it, because it's a very complicated issue to update different objects.
Thank you very much for your question. It is indeed very relevant, and I have already hinted in my presentation that the problems of updating are related to the funding constraints. Large corporations who privately can do updating, like Google, for instance, Bing, resource that we are aware of, Yandex, they do not share their data in no form. And they cannot be used for commercial use or any other use which would characterize this data as as accurate. They say we can use this data, we update them themselves, but we are not held responsible for what you consider. So this form of responsibility can be borne only by state authorities, like we have Russian Cartography and military cartographic agency in Russia, who are responsible for what they share. But in Russia, the updating of this data, unfortunately, constrained by the lack of funding. And the structures that I've just mentioned are quite seriously concerned about the need to update, and they are now in the course of developing a number of technologies to shape up a single structure of geospatial data where all users could be, one, get their source data in form of in the original form, and secondly, put it there by going through certain certification procedures which would authenticate this data. This is not a quick process. It requires a lot of funding, as I said. And first of all, it requires introduction of new technologies. Naturally, I have my own opinion about this, because I'd say now we have a 50-50 split in between people who think that we need to upgrade to new technologies where this data can be kept into object-oriented databases, and then we can get information about the road Moscow-Vladivostok in all its attributes. But other people saying we don't need to do this. There's a structure, standard technology with the updating of nomenclature maps. We can also retrieve this data from there. And this discussion has been going on for quite some time already. As a result, we have, I'd say, wasted quite an amount of state resources, which led to a serious scandal at the level of Cartography, and unfortunately it hasn't led to any good result yet. But hopefully, in the nearest future, we'll make a progress, and as a proof of that, we can see what Minister of Defense has done. And they have implemented a huge project, Ministry of Defense Control Center, where they consolidated a huge amount of information, both from state-owned resources and also from other agencies and ministries. And that's where they implement this infrastructure of geospatial data. Maybe this defense ministry is much more diligent in what they do. Yes, thank you very much. Will there be other questions? I have a question. We have a question from the floor. You mentioned new 3D visualization technologies. Could you also say how demanding these new technologies are for the computing power and the software? It's hard for me to evaluate now how demanding they are. I can just say that the current development of servers, because servers are more important, because these are service-oriented things. There are some good, very productive working stations. For them, of critical importance are the graphical memory, and working stations to shape up these images is not that difficult. You can buy a very good computer and you can easily visualize it. I'm not talking about stereo mode, I'm talking about 2D. But to get a 3D in web, first of all, for that you need very powerful server resources. And to resolve this problem, we need to establish gigantic swords, which would be able to process huge amount of data with many requests. And to do this at the level of small companies is impossible. This is a task for large state structures or corporations who are prepared to invest into establishment of such huge server centers. And the main demand is to have a high level of graphical memory. Okay, more questions? Then I have a question. Sometimes we need to speak about commerce as well. In our work, it is known that your company is performing a lot of work related to developing real GIS. What is the structure of customers. Who do you get most of the orders from? If we take, say, state, municipal, or corporate customers.
So what's the customer structure? What's the percentage split in terms of shares? We have colleagues from the United States here in this room, and the sanctions that were imposed worked in favor of our small company. The structure of orders has reorientated itself toward larger corporations. At the moment, large companies come to us as a result of import replacement national policy. Previously, they would go to American companies or other companies. So, a year ago, the split was 70% individuals, 30% large corporations. Now, it worked the other way around. 30% are individuals and 70% are large corporations. Thank you very much. Thank you once again.